So, if you're looking to factorize some expressions which include indices in them, then here's a short video for you. You might like to watch in advance of this the other video, which is about multiplying and dividing with indices, because that will set you up quite nicely for this. Let's take an expression with two terms in it, which include indices. So let's take 5a squared b, which means 5 times a squared times b, plus 6 a, b, c. I'm just going to change that a little bit. Let's not make it 5a squared b, let's make it 5ab squared, and then we will add 6abc. Okay, factorising is putting expressions into brackets, finding highest common factors of the two expressions, and then putting the expression into brackets. Is there a common factor of 5 and 6? No, there's not, apart from 1. Is there a common factor of a and a? Yes, there is. You can divide a and a by a, can't you? Now then, we've got b squared and b. Here's where our indices come in. Obviously, I can divide b by b. Can I divide b squared by b? Well, if you watch my video, you'll know that you can, because b squared divided by b will be b to the power of 1, or just b. Let's write it out. Long form b times b divided by b. If you write it out like that, like a fraction, then you can cancel your numerator and denominator down. You can simplify by dividing your top and bottom by b. If you do that, then that just leaves you with b over 1, which is just b, isn't it? So in this expression here, where we have b squared and b, hopefully we understand that we can divide both of them by b. So b squared and b can both be divided by b. And we have a c in the expression on the right, but there are no c's on the left, as we can't divide them both by c. So that's it for our common factors. Open up the brackets. 5a divided by a is 5, and b squared divided by b is b. And on the left, 6a divided by a is 6, and b divided by b is 1. 6 times 1 is what? 6, and we have our c there. And so we get an answer of ab brackets 5b plus 6c. Let's do a couple more with slightly larger indices and see how it works. Deliberately, by the way, giving no common factors to the integers, the numbers, so as to keep life a little bit easier. 5a cubed, b cubed, c cubed, there we go, minus 15a squared, b, c to the power of 4. Okay, 7 and 15 have no common factor. A cubed and a squared, can you divide them anything? Well, yes, you can divide them both by a, can't you? Can you divide them by anything more than that? Well, actually, you can obviously divide a squared by a squared, can't you? Can you divide a cubed by a squared? Let's have a look. A squared, a cubed is a times a times a, and if you try and divide it by a squared, that's a times a. Again, if you simplify your fraction by dividing by a and by a again, you'll see that it does go exactly, doesn't it? Because it leaves with a on top and 1 on the bottom, which is a. If you've watched the earlier video about dividing with indices, you will already know that. You'll know that a cubed divided by a squared is a to the power of 3 minus 2, which is a, isn't it? Fantastic. So, hopefully, you'll understand then that we can divide a cubed and a squared by a squared. B cubed and b can both be divided by b, can't they? Nothing bigger than that, because b is the highest common factor of b. You can't divide something by anything more than itself. And c cubed and c to the power of 4, or we can divide them both by c. We can divide them both by c squared. We can divide them both by c cubed. C divided by c to the power of 4 divided by c to the power of 3 is c to the power of 4 minus 3, which is c to the power of 1, which is c. Write it out longhand again just to show you. C to the power of 4 divided by c to the power of 3. C divided by c is 1. C divided by c is 1. C divided by c is 1. We're just cancelling a fraction that's got letters in it rather than numbers. It's the same thing, but with letters instead of numbers. So that leaves on the top with c, and on the bottom 1 times 1 times 1 is 1. C divided by 1, of course, is c. So we can divide top and bottom by c cubed. C cubed goes into c cubed, and c cubed goes into c to the power of 4. So on the left-hand side, 7a squared divided by 7a cubed divided by 7a divided by a squared is 7a, because a cubed divided by a squared is a. B cubed divided by b is b squared, and c cubed divided by c cubed, something divided by itself is always 1, isn't it? So 7ab squared times 1 is just 7ab squared. That's that. And on the right-hand side, minus 15a squared divided by a squared is minus 15. The a squareds cancel out. B divided by b, well, that cancels out. And c to the power of 4 divided by c to the power of 3 is just c, as we talked about down here. Okay, and that's our expression factorized. That's a couple of examples of factorizing expressions which include indices. In principle, that's it. I can't emphasize enough that probably watching the previous video on multiplying and dividing numbers with indices will probably set you up quite nicely to understand this particular topic.